G'day, copy the heading down and then we'll do some hard yakka. Chemical symbols go back a long way, but were pretty messy. The world of the alchemist was really chaotic, with astrology, cats, crystals, and rather odd people searching for ways of making gold from whatever they could get hold of. English chemist John Dalton cleared most of the mess away by publishing his new element theory. Elements had one type of atom, and he gave them symbols. Compounds had more than one type of atom, but his symbols were still a bit off the plot. Well, here's Mr. Fix-It Man, Swedish chemist Johns Berzelius. Let's have a look at some of his element symbols. You have a capital letter that is usually followed by a small letter. That second letter must never ever be written as a capital. Let us imagine that you have been eating too much fruitcake and wrote the symbol for cobalt with capitals. You will be changing its symbol to that of the poisonous gas carbon monoxide that is killing the red blood cells of anyone who goes near cars. It is easy to distinguish between elements and compounds using the chemical formula. Elements have one capital. Write down E for elements and C for compounds in this list. Elements have one capital. I hope you get to play with lots of compounds like copper sulfate. That is the joy of chemistry. Copy down this table with the headings and we will fill it in. It's time to fill in the metals column of the table. For each metal, write the metal name, the old names, and the symbol. Aluminium is a lightweight silver metal with the symbol Al. Silver was known to the ancient Romans as argentum, hence the symbol Ag. Gold is found in nature as the pure metal. The Romans called it aurum because it shines like the sun, so it has the symbol Au. Calcium is a reactive grey metal found in a range of natural compounds such as limestone. It has the symbol Ca and used to be known as lime. Copper is an old metal dating from before the Bronze Age. The Romans obtained much of their copper from the island of Cyprus. They first called copper cyprium, then cuprum, so its symbol is Cu for cuprum. The common metal iron was the second great metal of history, replacing bronze. The Romans called it ferrum, so we have its symbol Fe. The highly poisonous liquid metal mercury has been known since ancient times. The Romans called it hydrigarum, meaning liquid silver, hence its symbol Hg. Potash or potassium carbonate was the material that could be extracted from wood ashes. From this is extracted the grey, soft, explosive metal potassium. The Romans called potash kalium, so we are stuck with the symbol K for potassium. Magnesium is a lightweight grey metal with the symbol Mg. Sodium is a soft grey, dangerously reactive metal that can be extracted from table salt. The old names for its salts were soda and natrium, hence the symbol Na. Lead is a soft, poisonous, dark grey heavy metal. The Romans called it plumbum and used it for plumbing. So we use the unusual symbol Pb for lead. Silicon is a grey semi-metal with symbol Si. Silicon is found in sand and most rock minerals. Tin is a shiny grey metal. Its old name was stannum, and its symbol is Sn. Zinc is a grey metal used to coat and protect iron. Its symbol is Zn. Metals had a metallic shine and were particularly valued by the ancient metalsmiths for their malleability. They could be moulded, pounded and filed into shapes. Non-metal elements are quite different. They can be brittle solids or gases and occasionally liquids at room temperature. It is time to fill in the non-metals of column 2. When non-metals form the second parts of compounds, we change their names to IDE words. So for each non-metal, you are to write down first the name, the IDE word, and then the symbol. Fluorine is a deadly poisonous pale green gas that is extracted from fluoride, the mineral that fluoresces or glows under ultraviolet light. Chlorine is also a deadly poisonous gas used to kill germs in drinking water and swimming pools. Bromine is an evil red liquid that can burn your lungs out. Iodine is a purple-black solid used to disinfect wounds and to sterilise skin before operations. Oxygen is a colourless, odourless and tasteless gas that combines with things when they burn or rust. We slowly burn our energy food using oxygen in order to stay alive. Nitrogen is a colourless, odourless and tasteless gas that makes up 78% of the air. It is a vital part of all living compounds. Phosphorus is a red or white solid. It is also a vital part of living compounds, but the element itself is poisonous, particularly the white form. The colourless gas hydrogen is the lightest element in the universe, and the most abundant. Carbon is usually a black element and the main element of life. A radical is a person who is just a little bit different. Radicals in chemistry are clumps of atoms that tend to stick together during chemical changes. Radicals have at least two elements in their formula. In the first example, there is one hydrogen, one sulfur, and 4 oxygens. Notice that we leave ones out of the formula to save us time when writing the formula. Radicals make up half a compound and are given one name. Please fill in the third column of your table with radical names and formula. Ammonium, nitrate, hydroxide, sulfate, carbonate, bisulfate, bicarbonate, phosphate, Well done! Rule off the table and copy down these simple rules. In our first example, we want to name the formula for coral. We split the formula into two bits that we can recognise and name them both. Coral, shells, limestone and tooth are all examples of calcium carbonate. Here we have the formula for the brown pigment used in ancient Kakadu Aboriginal art. We hit the formula with an axe. The second bit is a non-metal, so we use the IDE word oxide. Now it's your turn. This is fluorite ore from Broken Hill. We split the compound into two. The first part is zinc, the second part is the non-metal sulfur, so it becomes the IDE word sulfide. This is poisonous cinnabar, used in ancient girls' makeup to drive the men crazy. This saltpeter was made from mixing manure and urine. A key ingredient in gunpowder, it sent people to St. Peter. Again, we split the compound into two. The second part is a radical, so its name is unchanged. You are looking at two deadly gases being emitted by hot springs at Rotorua in New Zealand. If we continue to make our oceans acid, bacteria will make these gases in quantity in the oceans. We believe this has happened in the past and led to mass extinctions. This is fool's gold. Scratch it on unglazed porcelain. If it leaves a black mark, you are a fool. When batteries corrode, this salt leaks out and ruins your appliance. The old names for this chemical are bluestone or blue vitriol. When heated, it yielded oil of vitriol or sulfuric acid. This acid can be made by distilling common salt with sulfuric acid. Its old name was spirits of salts or muriatic acid. The best neutraliser for this acid in the laboratory is bicarb soda. Nitric acid can dissolve most metals except gold. It can dissolve U and copper. The brown gas seen is nitrogen dioxide and is very dangerous, being a part of car pollution. The blue salt being formed has an interesting name. There are two salts here. The first can be used to etch copper circuit boards. The second is a cheap fertiliser that unfortunately kills gum trees. Here are two interesting chemicals. The first is bugle protector and the second is a fertilizer. These are two acidic salts. The first was called green vitriol. The first chemical was used to make acetylene in old miners' lamps. The second is a slaked lime used in cement and agricultural lime for the garden. The solutions are lead bromide, potassium iodide, silicon oxide, lead nitrate, aluminium oxide, silver fluoride, sodium nitrate, potassium hydroxide, and ammonium hydroxide. We might visit one more skill before concluding this tutorial. Some elements combine to form more than one compound. In these compounds, the name often includes prefixes. Copy these prefixes down. The prefixes tell you how many of each atom are in the formula. The first example is carbon tetrachloride, CCl4, a banned cancer-causing chemical that used to be used in dry cleaning. The prefix tetra means 4, so carbon tetrachloride has 1 carbon and 4 chlorines. The second example is carbon dioxide CO2. Di means 2. It has 1 carbon and 2 oxygens. See if you can write the formulae for these chemical names. The story goes that young William on the left visited his grandmother, Queen Victoria, at Balmoral Castle in 1862. His dad is on the right. When he had grown up, William visited the grand British city of Bath and drank some mineral water. He was then forced to spend a lot of time on this appliance invented by a man called Thomas. Kaiser Bill was not amused and went back to Germany. Can you name these 2 chemicals in the mineral water that could well have contributed to World War I? Oh dear. Till next time, cheerio.